there is x of t, the Fourier transform of x of t is nothing but x of omega. Okay, if you have x of t, you're going to get Fourier transform of x of t is nothing but x of omega. Now xt into e to the power j omega naught t, this value, that is what we have discussed here, no, that this value will going to give you x of omega. This will going to give you frequency shifting, frequency domain shifting, x of omega minus omega naught. If you have x of t into e to the power minus j omega naught, it will going to give you x of omega minus, plus omega naught. Clear? Now if you add both this term, and multiply, just multiply 1 by 2 here. If you add both this term and multiply 1 by 2 here, you are getting 1 by 2. Okay, let's forget about 1 by 2. If you add normally both these terms, then you will be getting x of, look here, x of capital X omega minus omega naught plus x of omega. What I did a simple addition of these two things, these two equations. Okay, the important part is, if you multiply 1 by 2 here, the Fourier, these things are actually Fourier transform. Okay, all of these are Fourier transform. Okay, now look here carefully. If you just multiply 1 by 2, you can see here, this is nothing but divided by 2 only. This is nothing but divided by 2 only. This is nothing but divided by 2 only. 1 by 2 x of omega minus omega naught plus x of omega plus omega naught. Now this expression is nothing but cos omega naught t. Okay, now x of t into cos omega naught t, that will going to give you this kind of expression. Now what is the conclusion here? Very important conclusion for your communication control system, lot of NT. It's a very important conclusion. If any function, when it get multiplied with the cos omega naught t, it will going to be defined at 2 points. At one frequency component, that is omega naught, and another one, that is minus omega naught. That means at these 2 points of frequency, or at this position of frequency, this your x of t will going to be defined. Okay, how? I'm going to show you here in graphically. Look here, if this is your x of t, when this x of t is multiplied with cos omega naught t, simply if you take the Fourier transform of cos omega naught t, we saw that it is generating 2 pulses at this value, that is minus omega naught and plus omega naught, right? Now if you are multiplying this function, some function x of t, whatever, when with this cos omega naught t, that means this function will going to be defined at this value and at this value only. This is the concept of frequency shifting, and this is the concept that is we call as modulation, that we're going to have a brief discussion, core discussion in communication subject. Okay, I'm not getting into that, but please remember this thing, any function, it is so beautiful concept is, any function when it multiplied with any cos omega naught t or sin omega naught t, they're going to give you this value like this. This is only defined at these 2 points, that is minus omega naught and plus omega naught. Now what is the coordinate of these two value? What is the coordinate of this value? I'm not going to explain to you, I'm going to explain it to you communication subject. Okay, this will be nothing but, if your message signal, this is your message signal, this is your normal or input signal. Now the frequency value that is it is associated with it is like its range is minus omega m to omega m. That means this value will be omega naught plus omega m, and it will be omega naught minus omega m. So we're going to have a brief discussion in communication. I don't want to, like, if I start speaking about this, this lecture will going to be too long. Similarly, if there is any function which is having like is multiplied with the sin omega naught t, then that means in answer you're going to get 2 this function is only defined at two values of pulses. We know what kind of pulses that we got generated in sine omega naught t, like this kind of pulses. So that means this will going to be defined, this will going to defined, this will going to defined, one is here, one is here, and one is here. Clear this concept? This is a very simple concept, and on this concept there will be tons of questions that can be asked. Now I'll discuss one question that is nothing but e to the power minus 10 mod cos 20t. If you have this kind of question, that is, it is saying a Fourier transform, find the Fourier transform that is g of t, which is nothing but e to the power, it is a double-sided exponential signal, it is a double-sided exponential signal, it's a double-sided exponential signal when it is multiplied with cos 20t. Sir, it will going to give you two value, one is at this point, that is, and another one is in this point. Yes, I know that. I need to find out the mathematical format, how we should calculate quickly for GATE exam in mathematical format. That we are going to discuss here. Look here carefully. E to the power minus 10t, let's take it as x of t. So while you are finding it out solution, look here carefully. E to the power minus 10t, 10 mod t into cos 20t. This is your question. Now you need to take this as your x of t into cos 20t. Okay, now if you do in this way, that means the Fourier transform of this thing, Fourier transform of this thing, Fourier transform of this thing will going to give you 1 by 2 x of omega minus 20 plus omega x of omega plus 20. Clear? This is the value that you're going to get. It is the actual, like, the format of frequency shifting that we have studied till now. Well, 20t is actually cos and sine terms is nothing but consists of complex exponential signals, and they do provide, or they do help to shift your value in frequency domain. That is, they do help to do the frequency shifting thing, and we know this thing. Okay, now this is the value that we got. Now this is the answer. Okay, we got the answer like this. This is your answer right now. Okay, now you need to know what is the x of omega is. If you know what is the x of omega is, you can find out what is x of omega minus 20, what is x of omega plus 2t. Now how to know x of omega is, we know the double-sided signal. If there is a double-sided signal, we I think I have discussed with you the standard formats in exponential, real exponential, Fourier transform of real exponential. I have discussed with you the standard format. The double-sided signal, the Fourier transform of a double-sided signal will be nothing but how much? 2a, if it is e to the power minus a mod t, then the Fourier transform will be 2a divided by a square plus omega square. Something like this came na. So that means here what will be the value? X of omega will be how much? So x of omega will be nothing but, so I'm just equals to, x of omega will be nothing but 2a divided by a square plus omega square. That means 2 into minus 10. Yes, 2a mod hota hai na, was like mod or something. So I'm sorry, 2a is this. Okay, why it is minus 10? No, it is not minus 10. Minus is like a is not associated with the minus. Okay, so 2, it's not mod thing. 2a, 2 into 10. A is not negative here. Okay, 2a, I need to find out a. A is not negative here. Negative is in the format. Okay, so 2a means 2 into, what is the value of a? A value is 10. A value is not minus 10. Please have clarity in this thing. And a square, that is 10 square plus omega square. Okay, this is your value. This is a value that is 20 by 100 plus omega square. Now this is your x of omega. Now you need to write it down in this format. So that means 1 by 2, our answer will be 1 by 2, 20 by 100 plus omega minus 20 whole square plus 20 by 100 plus omega plus 20 whole square. Clear with this concept? This is nothing but your g of omega. Okay, this is how you need to do it. This is the quickest way to solve this question. Now the last question that I want to solve, this is a very simple and very important question. It is saying the Fourier transform of this following signal, that is g of t. Now you can clearly see this g of t. Look here careful, this is your g of t. Okay, now how you need to break it? It's a very simple way to break it. You just need to have a little bit general knowledge. Look here, you just need to, this is nothing but it can be seen as, it is a multiplication of two functions. What are these two functions? Very important example, my dear friend, do not neglect it. It is a multiplication of two functions. One function is cos omega t. Okay, this is a cos function, which is nothing but minus pi by 2 to pi by 2. Yes or no? And also a rectangular pulse which lies from minus pi by 2 to pi by 2. Okay, with magnitude 1. In the next video lecture we're going to have a get clarity on this thing, but right now I'm just giving you, because there is a very important question type. This one is a very important question type. Okay, so this is your f of t. Look here, this is your f of x of t, and this is your cos t. Okay, we came down to this format only, no? So g of t is nothing but x of t into cos t. We came down to this same format. Now it's a very important thing. So what will be the value? The value will be nothing but how much? This is the same thing, no? What will be the value? 1 by 2 x of omega plus omega naught x of plus x of omega minus omega naught. Now what is the omega naught value is here? The omega naught is 1. So x of 1 omega plus 1 and omega minus 1. Clear? Now what is the x of omega here? That is the interesting part. Your x of t is this. What is the x of omega? What is the x of omega? About this thing I'm going to discuss from the next video lecture. Please remember, if there is a rectangular pulse, the x of omega, the Fourier transform for rectangular pulse is nothing but a sinc function. Will be nothing but a sinc function. What is the value? The value will be pi sinc. You can write down in this way, or you can write down in this way, w into pi by 2, or you can write down in this way, sinc w into pi by 2. Anything that you can write down. So pi sinc of w into, or omega into pi by 2. This is the value of x of omega. This is your x of omega is. Okay, now here your final answer that you are going to get, g of omega, you got here 1 by 2. Okay, this will be your answer. Thank you so much for watching this video lecture. Please go through all these examples, please go through all these concepts. In the next video lecture we'll get into the Fourier transform of different pulses, where we are going to study this kind of concepts. Okay, here you need, what are the things, very important things that we have studied here. We have studied about the Fourier transform the Fourier transform of a complex exponential signal. Then we'll got into the Fourier transform of periodic signals. Then we went through time shifting properties, frequency shifting properties, and couple of important problems which are associated with the frequency shifting and time shifting properties. And at the end we have also discussed about how the questions can be asked from frequency shifting property in this format. You can break it down in this way. Okay, in the next video lecture we'll get into the Fourier transform of pulses. Thank you so much. See you in the next video lecture. Bye.